under miscellaneous substitution is fractional powers times. I will give you a simple overview and an example of this technique. You should let x equal to z raised to n, where n equals the common denominator. As an example, the integral of dx over x minus square root of x. Since x has an exponent of 1 and square root of x has an exponent of 1/2, we should get the common denominator by multiplying 1 and 1/2, which we will get 1/2. Therefore, the common denominator is 2. From now, we should follow the overview and let x is equal to z squared, and we can get square root of x by square rooting both sides, and we can get the square root of x is equal to z. Therefore, dx is equal to 2z dz. Moving on, substitute from the original equation, dx is equal to 2z dz over x, which is z squared, and square root of x, which is z. Factoring out 2 and z from the denominator, we will get 2 times the integral of z dz over z times z minus 1. We can cancel out z from the numerator and the denominator. And we will get 2 times the integral of dz over z minus 1. And with basic substitution, we can let u is equal to z minus 1, therefore du equals dz. Substitution from the equation, we can get 2 times the integrand of du over u, which will equal 2 times the natural logarithm of z minus 1 plus z. And what is z? It is only square root of x, therefore 2 times the natural logarithm of square root of x minus 1 plus z.
One of the techniques in integration is integration by parts, or IPP. This is applicable when the problem is a product of logarithmic, inverse, algebraic, trigonometric, and exponential functions. The general formula used for integration by parts is the integral of u dt is equal to uv minus uv. So here, I am going to give you an example. Let us find the antiderivative of the integral of x cosine of x dx. So first, we will let u is equal to x, and du is equal to dx. Next, we will find the dv. dv is equal to cosine of x dx. Then d is equal to sine of x. Substituting into the formula, uv minus the integral of ddu will give us x sine of x minus the integral of sine of x dx. So the resulting equation will be x sine of x minus integrating sine x dx will give us negative cosine of x plus z. Finalizing the answer, final answer is x sine of x plus cosine of x plus z. Another method of integration under miscellaneous substitution is the half-angle substitution. Formulas included are cosine x, which is equal to 1 minus z squared over 1 plus z squared. Sine x is equal to 2z over 1 plus z squared. Dx is equal to 2dz over 1 plus z squared. And z, which is equal to tangent of x over 2. Here we have our first example, which is the integral of dx over sine x plus 1. Then substitute the given values into this example.